problem. Okay, what is mobile map technology? Mobile map technology is a library. It's an open source library. The repository is here. We have a GitHub repository. Probably we go to change to Eclipse repository in the next few weeks. You have here all the code, information about work with the code and the issues, pull requests, and a little wiki with get starting and how to configure the library to work with it. You can find on GitHub Lob3 mobile. It's very easy to find. Okay, this library is developed to build native maps 3D applications. It's 3D because the world is not flat, the world is in 3D. The maps going to be all of them in 3D. You can build native applications and that runs on any device. The idea is you can reach any device that can work with a map. We have to face a lot of problems to work on the native way and to work on the mobile. The first of problems is the fragmentation. The people that who is working with mobile knows that we have fragmentation in the hardware and fragmentation in the software. We have 1,000 of different devices with 1,000 of different screens with different processors, different memory, etc. We have problems also with the fragmentation of the software. Different operating systems, different programming languages. This is a very big problem when you going to start to develop a map application. We face that. Another problem is the performance. The maps, concretely the 3D maps, are a very high performance applications. You need to do a lot of things with the device. You need to download a lot of tiles, a lot of information. All of this is in real time. You need to do a lot of async tasks, different things that you need to use the 100% of the device can do for you. This is the reason why we have developed a native application, a native library. Most of the approach for develop mobile maps is with web applications on the mobile, but this approach is not working always because in a lot of cases we need higher performance. Another problem is the usability. All the maps that are that was developed for the web are thinking the usability of the web, but the usability on the mobile devices is different. The resolution of your finger is different of the resolution of the mouse. This is one of the cases, but clearly it's absolutely different to develop mobile application than web application. And the other idea is easy to code. We need that you can start with the library in a very easy way because the problem is complex. How we can develop native application in all platforms? The magic here is with the code translation. We develop all the OpenGL because we have a 3D library. We have a lot of OpenGL work. All this work, all this complex work and all this code is developed in C++. Why in C++? Because with C++ we can work on iOS devices, and C++ you can compile. You have a C++ compiler on any platform. It's the minimal common. But we have the core in C++. With this core, you can see the maps on iOS, and we translate the code to Java. And we have an Java API, a Java native API, but that is developed in C++. The Android developers only have to work with a Java API. They don't have to worry about how the C++ code is done. The code is legible, but for us it's like a compiled code. And we make another code translation with Java LBT, and we read all the web devices. At the end of the day, we have an iOS API, an Android API, and GWT API. When you start an application, you can share a lot of code. For example, the GWT, the web application and the Android application can share the 80% of code because you only have to develop the user interfaces. If you develop your application also translating code, you can share also a lot of code between iOS and native. The C++ code, we have some abstract classes that allow us to connect new platforms. We can connect, for example, we have a port for Windows 8 that is working. It's not completely working now currently, but we only have to compile the C++ in the Windows environment. And in this way, we can compile. We can have on any platform when C++ runs. As I told something is multi-platform. This is iOS device. This is on Android. This is a typical use case where we have 3D models, we have a map, we have terrain, and we have another 3D model that is moving. It's a plane that is harvesting the data from the plane and is flying. And this is a map with 3D symbology. We have a lot of different types of symbology. This is a web, and this is working on Google Glasses. Like the Google Glasses Android, we only have to run the platform on the Google Glasses, and it's working slowly but works. This is a different views that we have. This is a 3D globe view, is typical the Google Earth, but it's the globe view. This is the scenario that is a part of the terrain. This is a scenario with a digital model of terrain. This is a flat view. It's flat, but it's 3D also. You can move in a similar way that the canvas of JavaScript. We can show any kind of data or geodata. We don't have developed the parsers, but we have developed different tools to translate the data to optimized format that we use to show on the globe. Why we don't develop parsers? Because there are 1,000 of parsers of data that works very good, and we only need to see well on our platform. This is normal pictorial data. This is, as I said previously, 3D buildings from OpenStreetMap. Terrain, this is a point cloud, raster data, 3D models, typical data from Geo. There are another different capabilities that have the library in order to build mobile applications. For example, we have a complete control of cache to save data. You can develop completely offline application. All the things that you can ask to a server, we can save on a SQLite database. And the database are interchangeable between platforms. You can prepare the database, and after that you have the mobile application. Normally, the mobile application is not only a client problem. It's a client and server problem. Not there are all the mobile applications are different. Always the capabilities are different. You have to follow a different strategies, and the library gives you the possibility of implement all this kind, all these things. As I said previously, we can manage the cache. Well, it's very easy to do. We have camera and model animations. We have different utilities for develop the application. For example, tags. We have developed a hat for glasses, and a lot of tools to transfer the data. This is for an example. It's one of the last things that we have done. Is symbology. I have a video. This is on iOS. There are markers, but never overlap between them. It's an example of symbology. It's a different symbology. We have also different libraries that works in our library, and that works with other software. For example, we have a library of vector tiles. This library, we get the data from a PostGIS database. We have a process. We make a pyramid of vector tiles, and you can serve these tiles in a normal web server. Like all the format of the files are JSON, and you can serve in a normal web server. There's static data. This is an example working on OpenLayers 3. Is the pyramid instead of rasterized data is directly a vector data. You can, for example, you can change the symbolization on the fly. Okay, this use case is data from ports, from the currents and sea, and all the things that you can have in the port, and it's in real time. You can use that in real time. This is a web application. This is one of our last development. Is a library to show point clouds, a very huge point clouds on 3D point clouds. I want to show you a demo working. This point cloud is 150 million point clouds. We pre-process the data. We serve always points that are meaningful. If you go, we are serving only 10 points, but these points are saving the shape of the point cloud. And we have developed the preprocess library, and we have developed a streaming server. Depending on where you are, we serve only the points that you need to show your data. For example, the points are coming, and it's completely 3D. We can show that. This is web. It's the last part of our library, but you can show this on Android, on iOS, in the same way with the same code. Well, the points are coming from the server. how we do that? We have we get the data, we import the data to Berkeley DB, which is very fast. We need a very fast database to process the data because they are very huge, always the point cloud. Important, we order the point cloud, we prepare a pyramid in the same way that the vector tiles, and we have a server for the point cloud streaming. We have a native support on the MNT. As I said previously, we always save the shape of the point cloud. This is another example. This is a point cloud on a local point cloud that is saved on the device. This is with my phone yesterday. The point cloud is saved on the device. It's parsing the data. You see, it's very fast. If someone want to play, I can give you the. This is a different approach. It's local. It's the point cloud is saved on the device. The other example is on a server. The server is a laptop that is in the office of my partner. It's working now. I want to show you a video with different. This is the application. That application is on the Google Play Store and also on the Apple Store. It's a summarize of different capabilities of library. This is raster layers, different raster layers. You can use any raster layer with any kind of tiles. For example, this is a CartoDB layer. But, it's very easy to show raster layer. This is two glows working at the same time on an Android device. You can put 8 or 9 or 10, what you want. This example is only a 3D model. A 3D model and raster data together. And this is a scenario. This is all of this is on Android. That where we have the worst performance, and it's very good performance in any case. This is vectorial data. They are your JSON files. That case is here. This is 3D symbolization. As you have a 3D environment, you can show the data in very different ways. For example, like this. And you can change the 3D models with time, etc. This is another point cloud. We showed a lot of point clouds. This is an example. It's a use case that is moving max for the planes. This is a plane flying. This is the plane taking off from the Boston airport, and the application is getting the data from the instruments of the airplane, and we show this map could be shown on the screens of the plane, or also on the devices of the passengers. This is the plane moving in the real way. For example, this is the view that you have about below the plane when it's taking off. The image is from a box. It's a normal raster data source. And there are a lot of different kind of views. Well, the special thing of this case is we have a 3D model. We have a lot of different kind of data working together. Works on any device. Could be a very good performance. And I think it's all. If you have any questions, it's the moment. And if you need something, you can write me an email or whatever. Thank you.